Welcome to this tutorial on how to create AI-powered XR lessons using EON Reality's EON XR platform. This guide is specially prepared for the NIMI Chennai team, showcasing how to transform your training content into immersive XR experiences. Once you're logged into the EON XR platform, you'll land on the dashboard. From here, head over to the top right and click on Create. In the Create section, choose Course Catalog. This is where you can begin building structured learning modules. Now, go to the Train AI section. This is where you'll upload your course material. In this case, I'll be uploading a PDF titled rooftopbook.pdf, which is a training manual on rooftop solar PV systems provided to us. Once uploaded, EON XR's built-in AI analyzes the content and automatically generates 5 interactive XR lessons. These lessons are fully editable and can even be translated into multiple Indian and international languages. For this demonstration, we'll proceed with the default language, English. After that, just scroll down and click on the blue Continue button to begin generating the lesson. Once you click it, you'll be taken to the status log. Think of it like watching cookies getting baked in the oven. Within a few minutes, your XR experiences will be ready and waiting. This marks the beginning of a more engaging and immersive way to deliver technical training content. Let's take a closer look at one of the lessons that was just created and see how it all comes to life inside EON XR.
These structures provide the physical support that keeps solar panels securely attached to rooftops, the ground, or specialized tracking systems. The choice of mounting structure depends on factors like roof type, site conditions, and desired panel orientation. On flat roofs, ballast blocks are often used to avoid penetrating the roof membrane, while sloped roofs typically require rail systems anchored with specialized fittings such as L-foot brackets. Ground-mounted arrays rely on components like ground screws or pole mounts to anchor panels in soil or concrete. Solar trackers, which follow the sun's movement, demand precise rail alignment and robust mounting to ensure smooth operation. Each mounting system must account for environmental loads, including wind and snow, to maintain stability and safety. Proper selection and installation of fittings, such as roof anchors, clamps, and torque settings, are crucial for long-term durability and performance. Tools like fitting selection guides and torque wrenches help ensure that every component is matched to the site's structural requirements and installed to manufacturer specifications. Structural blueprints and installation manuals provide vital reference points for adapting mounting solutions to different building types. All these elements work together, forming an integrated system that maximizes energy output, protects the building, and ensures the longevity of the solar installation.
With the training phase complete, where the AI avatar explains the core concepts, we now enter the engagement phase. Here, learners can ask follow-up questions, making the experience interactive and personalized.
What is the main use of ballast blocks?
Ballast blocks are heavy weights used to secure solar panels on flat roofs without penetrating the roof surface. They rely on gravity to hold mounting structures in place, minimizing roof damage. Proper weight calculation and distribution are essential to withstand wind loads and maintain system stability over time.
What are the main ingredients of pasta?
Please keep on topic. We are focusing on solar panel mounting structures. If you have more questions about that subject, feel free to ask.
It remains unresponsive to off-topic questions, ensuring focused and relevant learning. Now, let's move on to the assessment phase.
Welcome to the assessment phase. Choose from 3 options: a multiple choice quiz, adaptive questions, or a memory challenge using hints and past lesson content. Start quiz challenge. The timer begins when you press start. Which type of solar panel mounting structure is best suited for maximizing energy capture in areas with limited space? The Socratic assessment starts with an easy question and adapts in difficulty based on your answers, creating a personalized learning experience. Let's begin with an easy question. What is the primary purpose of a solar panel mounting structure?
The primary purpose of a solar paneling structure is to mount the solar panel safely and ergonomically.
Great. Now, let's move to a more intermediate question. Can you explain the role of ballast blocks in solar panel mounting systems, particularly on flat roofs?
Ballast blocks, according to me, on flat roofs are a rigid structure which help to keep the solar panel on its place and keeps it safe.
Ballast blocks are indeed used to secure solar panels on flat roofs, but they are heavy weights that rely on gravity to hold the mounting structures in place without penetrating the roof surface. They help minimize roof damage and are essential for withstanding wind loads and maintaining system stability over time. Test your memory by answering questions and earning points based on your performance. Start Jeopardy challenge. Go to the object identified, then press start. What is a weight used to secure solar panels on flat roofs without penetrating the roof surface?
Ballast blocks.
What is the component used to attach solar panels to the roof by connecting the mounting rails to the roof anchors?
Foot bracket.
Welcome. I'm Priya Sharma, and I've seen my share of tricky installations. Let's get to the bottom of this instability and make sure our solar panels are secure.
Hello, I'm ready to investigate this with you.
A new solar PV installation atop the city's municipal building is experiencing unexpected instability and reduced energy output. As the lead solar engineer, you must investigate the rooftop, identify the cause, and recommend the right mounting solutions. Your mission will take you through a hands-on exploration of various mounting structures, fittings, and site conditions. The city's energy future depends on your expertise and keen eye for detail. You notice that some panels on the flat section of the roof are slightly tilted and wobble when touched. Nearby, you see mounting rails, ballast blocks, and a set of roof anchors. The installation manual mentions the importance of matching mounts to roof type. Which mounting structure should you investigate first to address the instability on the flat roof?
Ballast blocks.
Great observation. Ballast blocks are commonly used for flat roofs where penetrating the roof membrane is undesirable. However, if not properly weighted or distributed, they can lead to instability in the panel mounting support structure. Let's check if the ballast blocks are correctly installed and sufficient for the wind load. You confirm that the ballast blocks are underweighted for the site's wind conditions. This discovery prompts a review of the ballast calculation and installation method. On the sloped section, you see rails attached to the roof with various fittings. Some panels appear secure, while others have shifted slightly. You spot L-feet brackets, roof anchors, and a torque wrench. Nearby. Which fitting should you examine to ensure the panels are properly secured to the mounting rail? Sloped roof.
According to me, it should be L-foot brackets.
Exactly. L-foot brackets are essential for attaching mounting rails to sloped roofs, providing a secure connection to the roof structure. If these are loose or improperly installed, panels can shift or detach. Let's check the torque and placement of each bracket. You find several L-foot brackets that are under-torqued, explaining the panel movement. Adjusting and securing them improves stability.
Great job completing this lesson. Remember, this is just one of 5 XR experiences generated from the full PDF. So be sure to explore them all. And once you're done, you'll get a full summary, a detailed report, and even a spider chart of your progress. Happy learning, and see you in the next one.
This is your overview chart, and your score is final score 19%. Click on Summary or Details Report for more information.